Welcome to the Arithmetic Zone, and for this bonus video, I'm going to teach you some helpful math tricks for AP Physics, specifically the kinematics topics. So, if you want to find the roots of a quadratic equation, you have several options. But if you want to use a calculator, what you can do is press y equals and go on this menu right here. And then you want to graph your function there. And then on y2 right there, you enter 0. And then you press the graph button, wait for the calculator to draw both functions right here. Then you press second, trace, and 5 so you can find the intersection point. Then you would use the arrow buttons to move the function so that it's close to the root and press enter 3 times to get that root. And then to solve for the other root, you would do the same thing, just get close to the second root. So we're going to do an example to demonstrate this. So essentially an object moves so that its velocity is represented by that function. And we want to find when is it at rest. So if we want to find if something's at rest, you want to set its velocity function equal to 0. Now this function is unpleasant to factor. There's a constant, so you can't really just, factor out the x's individually and then set both the variables equal to 0. And then this is a decimal right here. So chances are using any of the basic factoring methods would just not work. So the best way to deal with this is to graph it in our calculator. So for starters, you graph your function in y1 in the y equals menu, and then don't forget the 0 for y2. Then after that, press the graph button, and then by going to the intersection screen, which you press second, then trace, and then 5, you line up this cursor right here using the arrow keys to get as close as possible to one of the roots. Then you press enter 3 times there, and then you get root 1 displayed at the bottom left. So that x value represents the first root right there. And then press second, trace 5 again, and then this time you move the cursor so that it's on the second root. Press enter 3 times there, and then you get the second root location at the bottom left right there. So we successfully found both of the roots at t equals 1.061 seconds and 6.828 seconds in the context of the problem. So using our calculator, we successfully found the roots of this quadratic equation, in which if we were trying to do another method, it would probably be much more difficult. Now we're going to move away from calculators for a bit and talk about integration. So when you're given a graph and you want to find the integral, what you would do is find the area underneath the curve. And then usually you would have to break that area up into familiar shapes. But a lot of people don't know how to do the area of a trapezoid. And the area of a trapezoid, if you know it, is very useful for finding the area underneath these curves. So essentially, it's half of the sum of both bases times the height. So I have this example right here. B1 represents this top, B2 represents the bottom. Height is the length between the both bases, and then you just multiply that all together times 1/2. Now trapezoids, they don't have to have these equal diagonals right here. One of the lines could just be vertical like that, while the other one's diagonal. You could still use the trapezoid formula to find the area of this shape, because the extra length of B1 is going to account for that extra area. And then trapezoids could also be sideways like this. And then in that case, you just want to rotate it in your head so that you could visually see how this one's B1, this one's B2, and then this length is H. So again, we're going to see an example. So an object's velocity is modeled below with this graph, and we want to find the displacement from t equals 0 to t equals 5. So if we were to do this using triangles and rectangles, then it would take a while, and I actually modeled out that process right here. So you would have 2 triangles within the trapezoid and then this one rectangle, and same thing for this. And if you were to add and multiply all those areas together, you would get 202.5 meters. But let's use the trapezoid formula instead. There's two trapezoids in this graph. So, and I also put in these B1, B2 in H marks so that you know how I derived these numbers. So again, half times the sum of the bases. So this distance is 1.5. This is 2.5. And then the height, be careful with the axis, it's 45. And then this trapezoid, it's slimmer, but it's taller. Base 1 is 1, base 2 is 2 in length, and then the height is 75. Multiply that by half, and then if we were to add those two areas together, we would get the exact same answer, 202.5 meters. So knowing the area of a trapezoid can be very useful when finding the area underneath these curves, which is a common problem on the AP exam. Now we're going to go back to calculators and talk about table of values. So when you're given a table of values and you want to find the equations, you could actually put the table of values in your calculator using the stat function. So there's a button called stat. You want to press that and then press 1 or enter so that you can edit and then go into this screen right here. And then you want to use the arrow buttons to navigate each cell. And then you can enter in numbers by pressing the enter button for each cell. And then after you do that, you press stat again, press right, and then there's a calc section. And then within the calc section, there's various functions that you can use with those values that you inputted. Usually you want to use either linreg, which is the fourth option, or quadratic, which is the fifth option, which, as you may guess, essentially takes your table of values and it makes a linear and quadratic equation respectively. And then once you do that, you go into this screen. So if you press quadratic, you gotta press enter 5 times in order for it to calculate. So again, I'm gonna have an example so that you can better see this process. So an object's position x of t is modeled below with this table of values. What is the acceleration at time t equals 2 seconds? Now, usually what you would want to do for these kinds of questions is use the equations of kinematics, because chances are this table represents a quadratic function, and then if this is the position function and it's quadratic, that means the acceleration is always constant. So that means you can use the kinematics equations, but if you don't know how to, then you can use the power of the calculator. So again, press stat, then edit to get to this screen. Then we're going to put in each of these values, and you don't want to leave out any, because especially because it's quadratic, and quadratic functions, their first derivative changes at a constant rate. So if I find the difference between these two numbers, and I found how much it changes between those numbers, it would probably be the same number. But anyway, you would put in these values right here as such, and then after that, you press stat, then navigate to calc, and then because this is likely a quadratic equation, we're going to navigate to the quadratic option, go to quadratic, then press enter 5 times right there, and then you get this screen which gives you the equation in terms of a, b, and c. So essentially the position function is 25x squared minus 3x plus 2.5. Now the question's asking for acceleration, so we're going to have to derive that equation for the velocity, 50x minus 3, and then we're going to have to derive again for the acceleration, which is just 50. And even though it tells us to find it at t equals 2 seconds, acceleration is constant, it's 50, so it would always be 50 meters per second squared. Anyway, that's going to conclude this video. I went over 3 basic math tricks that can really make AP Physics C problems for kinematics units much easier, especially for the multiple choice. You will always have a calculator for this exam, and I think it's important that you know how to use the calculator and use its full potential to get these questions correct. Anyway, I'll see you guys later.